Okay, welcome back to 20-2. We are going to learn about lesson 4 in what unit are we in? Unit H. Okay, and we are going to connect roots, zeros, and x-intercepts, which we're going to learn they're actually all representing the exact same thing, which that came up yesterday a little bit when Braden asked that question. So we are going to establish a relationship. Just looking for my highlighter. There it is. We're going to establish a relationship among the roots of an equation, zeros of a function, and x-intercepts of a graph. Okay, so roots of an equation, zeros of a function, and xints of a graph. Okay, they're all going to be the same, but we're going to explore. So, definition: a zero of a function is a value of the independent variable. Independent variable is x. Okay, just a minute, I gotta make sure that I make my x's right. Don't want to muck it up. Okay, so value of the independent variable, which makes the value of the function equal to 0. Okay, and then zeros of a function can be found by solving the equation f of x is equal to 0. So let's look at an example. Find the zero of the function where f of x is equal to 2x minus 6. Okay, so all we have to do is set this equal to 0. So 0 is equal to 2x minus 6. And then we solve for it. So the first thing we're going to do is we're going to add 6 to both sides, which is going to give us 6 is equal to 2x. Then we're going to divide by 2, and so then I get x is equal to 3. Okay, and yes, I'm doing my x's differently. Okay, so investigation 1, connecting roots, zeros, and x-intercepts in a linear relation. Okay, so connecting. The graph of y is equal to 2x minus 6 is shown. So the same as the function, it's just now we've written it as a graph. Determine the x-intercept of the graph algebraically and graphically. Okay, well, let's do graphically first because it's the quickest. So the x-intercept is when y is equal to 0, which is on the x-axis. This is when y is equal to 0, and we see that that's happening at 3. Okay, so graphically, we have done this. If we want to do this algebraically, we do the same thing. We just set it equal to 0 because we just said that y is equal to 0. So here y is equal to 0, 2x minus 6. Move the 6 over, divide by 3. Oh, I'm trying to do my x's different. There we go. Okay, so we did it graphically and we did it algebraically. So determine the root. Okay, so notice we're talking about 0, x-intercept, root of the equation. So it's just how, so x-intercept of the graph, 0 of the function. So the root of the equation, this right here, I'm going to move my 6 over, plus 6, 2x is equal to 6, divide by 2, and I get x is equal to 3. So I see that my 0, my x-intercept, and my root are all the same. They the same. Okay. And because, you know, maybe I'm a little goofy right now. X-intercept of the graph is the same as the root of the equation, which is the same as the zeros. So root, 0, and x-intercept are equal. Number 9, using the result from class example 1, state the connection between the roots of the equation, the zeros of the function, they really nail this in here, and the x-intercepts of the graph, the same. They are all the same. Roots of the equation, zeros of the function, x-intercepts of the graph. Okay? Alright, moving on. Investigation 2. So we're going to now look at a quadratic relation. This was a linear relation, a line, okay, in the form of y is equal to mx plus b, for example. Okay, now my quadratic relation is going to be in the form of ax squared plus bx plus c is equal to 0 for this first one. There's actually there's more ways that you can look at it, but this is the way we're going to do it. Okay, Jacques is determining the roots of the equation. He wrote the equation in factored form and uses the zero product law to determine the roots of the equation. Complete his work to solve for x. Okay, well, all I have to do is factor this. So I'm just going to write out what he has written. And I'm going to write my brackets. I'm going to write that x there, and then I'm going to ask myself what multiplies to be 6 that adds to be -1. Okay, I'm sure Cooper's yelling out the answer right now. So 3 and 2 have a difference of 1, and then it's the -3 that needs to, or sorry, it's the 3 that needs to be negative so that we get -1. So -3 plus 2, and then that means that x is going to be equal to 3 and 2. Okay, so the roots are 3 and -2, my bad. Okay. Okay, that's the roots of the equation. Now we're going to be stating the x-intercepts of the graph. Okay, so it's shown here. All we need to do is mark on here that that's an x-intercept equal to 3. This is an x-intercept equal to -2. Okay, so -2 and 3 are the Zint's x-intercepts. Okay, consider the function. Determine the zeros of the function. Okay, well the zeros of the function are when f of x is equal to 0, or in this case g of x. Okay, so we still set it equal to 0. We're still going to factor it the exact same way as we did before. So what multiplies to be -6, that adds to be -1. That's going to be -3 and +2. And then we set each one of those equal to 0, so x is equal to 3, x is equal to -2. Okay? So the connections between the x-intercepts of the graph, the roots of the equation, and the zeros of the function, they're all the same value. Or you could just say equal. Okay? Okay, so now we're going to look at determining the roots and zeros of x-intercepts algebraically. No, we're not. This is out of order. Psych. We're going to do class example 2. Oh, it's ripped. Okay, fill in the blanks of the following statement regarding the function with equation y is equal to f of x. Okay, so what word goes with function? That's the zeros. What word goes with graph? That's x-intercepts, which means the blank goes with the equation. That's right, the roots, and they are all the same number. Okay, so 0 is a function, so I don't know if there's like a way to, you guys want to remember this. If you can think of, that doesn't really look like it could help. Now it's going to sound like I swore. Anyway, you can do something to try to remember that. This one's easy, x-intercepts on the graph, or at least I think it's easy, but whatever works for you. Go for it. Okay, so then now we've got some blanks for this graph. So this is the graph that we just did. Okay, it's the same. So it has x-intercepts. We find them there at -2 and 3. Oh, and the y-intercept, which is at -6. This function here has zeros, of course, once again, -2 and 3, just like this has roots of -2 and 3. Okay? So this just kind of summarizes up what we've talked about so far with regards to zeros, x-intercepts, and roots, and so from an equation or from a graph. Okay, now we're going to use our graphing calculator. So, consider this function. Describe how the features of the graphing calculator can be used to determine the zeros of the function. Okay, well, if the roots are equal to the x-intercepts, which are equal to the zeros, okay, that just means we need to find the zero, so you do the analysis, and you find the zeros. So depending on your graphing calculator, there's slightly different keystrokes, but you can write in for what you do. For the inspire, you graph it in y1 equals whatever, or the function. Then you go menu, menu doesn't have a E, and then analysis, and then zeros. And then that's when you do left bound, right bound, or I think it says upper bound, lower bound. Okay, state the zero. So I want you to put this into your graphing calculators. Okay. So put that in, graph it, find the zeros, and maybe, Tamar, if you want to pause me. Okay. I'm hoping Tamar paused me, and then I'm going to tell you, so you should have found, using your graphing calculators, that those were the zeros. Okay? So if those are the zeros, then of course they're also the roots. And then the last part, draw the graph on the grid. So if, so these you notice are going up by ones, because that's 5, and there's, so that first 1/2 would go in between there. So that's one x-intercept, and then the other one would be right there. And the, I think the y-intercept's around there. I think it's 3. And then the max-min, you should know how to find that too. Which are roughly, wow, I'm really not doing that great at this. There we go. Okay. So draw the x and y intercept, so that's at 1/2, that's at 3, that's supposed to be at 3, and there's x-intercepts, y-intercept. Okay, so given a function, we figured out the zeros, the roots, the x-intercepts, and then you can also find the y-intercept, which if you can't read it off, remember you can use the table of values, and wherever x is equal to 0, y will be your intercept, y-intercept. Okay, one more page. 2 more examples. Okay, so determining root zeros and x-intercepts algebraically. So algebraically determine the zeros of the following functions. So this is the work that we did with factoring. Okay, so the zeros, that means 0 is equal to 3x, 4x minus 9. So you might have just, you might be quick at this and say, well, x is equal to 0 and x is equal to 9 over 4. Okay? As an aside, if you want to show this, you just take each one of these. 3x is equal to 0. 4x minus 9 is equal to 0. So if they're both equal to 0, then each are equal to 0. And then you just solve. Okay? Divide by 3. Well, that's still going to be 0. Here you'd move the 9 over. Plus 9 plus 9. 4x is equal to 9. Then you're going to divide by 4. So x is equal to 9 over 4. Okay? And then over here, I see, what do 5, 15, and 20 have in common? Pretty sure we did this exact example. So you would factor out the 5, and then you'd have that. Maybe it wasn't. And then you need to ask yourself, okay, so you make your brackets, put your x's, and you ask yourself what multiplies to be 4, negative 4, that adds to be positive 3. Okay, well, 4 times 1 has a difference of 3. So then you just have to put the negative 1 there. So plus 4, negative 1. Okay? And then I shouldn't forget that this is all equal to 0, right? Because f of x is equal to 0 if we're determining our zeros. So this 5 doesn't do anything because it doesn't have a variable attached to it, but these ones will. So we have x is equal to -4 and +1. Okay. So algebraically determine the x-intercepts of the graph of the function. With this equation, state the y-intercept of the graph. Okay, so we want the x-intercepts, we want the y-intercepts. So algebraically determine, that means we are going to have to factor this. I'm just going to write it out again, plus 10. So now I'm going to have to use decomp. So I do 3 times 10 is 30. Okay, and that's my a times my c. My b is equal to -11. So I'm asking myself, okay, what multiplies to be 30? That adds to be -11. Okay, so 6 and 5, and then we would just need to figure out, okay, where do we need to put the negative signs, whichever. These would both have to be negative. So then -6x plus, oopsies, sorry, -5x plus 10. And then we group. So what's common in 3x squared and -6x? That is a 3x. And then I'd have, so 3x squared divided by 3x is x. -6x divided by 3x is going to be -2. Then I'm going to do the same thing over here. So I'm going to take out that -5, okay, because I want x minus 2 again. And so if we just double check, -5 times x is -5x. -5 times -2 is +10. And then I just need to, oops, I don't know why I wrote that. So I would group them together, 3x minus 5 and x minus 2, which then gives me my x-intercepts. So you can do it the quick way. This would be 5/3 and 2. Or you set each of these equal to 0. So 3x minus 5 is equal to 0. X minus 2 is equal to 0. And then you rearrange them. So this is going to be +2, +2, +5, +5. 3x is equal to 5. And then divide 3, x is equal to 5/3. Okay, so we've done the first part. We answered what the x-intercepts are, but now we still have to answer what the y-intercept is. So I'm just going to do that right over here, I guess. So now my y-intercept is defined by having an x that is equal to 0. So then I just use this equation right here, and I substitute in y is equal to 3 times 0 squared minus 11 times 0 plus 10. Okay, well these first two terms are going to be 0. So y is equal to 10. Okay, so my final answers, I probably want to x-intercepts 5/3 and 2. Y-intercept is 10. And so just put a box around it. Alright, that's the lesson. So this was lesson 4. Your guys' next quiz, where does it say? It's tomorrow, but you have the first period to just work. So make sure you do a little bit of homework tonight so that you can come with questions tomorrow as per what you need to know. So here's just so you're gonna study, then you're gonna write your quiz. We have an early dismissal on Friday, and then we just start again. The end is near. Yay. Okay, hope you guys have a great day, and hope that I didn't swear. Bye.